Hello and welcome to this C tutorial. If you're watching this, you're one of the lucky few that I've blessed with the link to this video. And well, yeah, welcome. Glad that you're here. So, you're here to learn a bit of C, right? So I'm assuming you have Visual Studio Code set up and it works, right? So easy way to check that it works is to go terminal, new terminal, and type G++, right? And if you get this fatal error thing, it works. Don't worry if you don't understand what that does. Perfectly fine. Just if that's just a check, right? Just make sure it works. Okay. First of all, this video is a little bit unstructured, so this is just going to be me recording something for sort of the fun of it, but also hopefully to help you. Also, I'm not a lecturer. Pre-warning. Might be a little bit obvious, but I'm not a lecturer. I'm just a student, and I have a few years of experience with C, so I thought I'd try and share my knowledge with as many people as I can, if they're nice people. But anyway, time to get into the C thing. So essentially, this is Visual Studio, and it's split up into a few different sections, and I won't spend too long on this because it's probably a little bit boring. However, it's good to make sure that you know where everything is. So this space here, this is the main window, right? This is where all the code will be, any text files, any database files you want to edit, it's all going to be in here. This is where you'll be coding most of your stuff, and you can do some things like split windows, so you can have two files open at the same time, but we don't need to worry about that now. For now, we're just going to be coding in one file. Over here on the left is your file explorer, and this is where you'll see all of your open editors, which is essentially all of the files that are here, and then your project file, which is going to be where you store all of your files for your coding, obviously. At the top you have the toolbar with all of the things on it that you expect, like file, save. You can click autosave and it will automatically save your work. I have it switched on. And then you have like view and terminal and stuff like that. Also, I have a drink. So, sorry if I drink from time to time. I do have a sore throat. It's not that sore, it's just like cold. I've got off lucky. I've not really been affected that bad by freshers' flu. It was one horrible day. No, it wasn't very horrible. I was just sick and tired. So, a couple useful things here. There's search. We'll get onto this in a bit. This is very useful because you can search for a specific variable name and then replace it with something else. So if you wanted to rename a variable for whatever reason, you can rename the whole project in this one thing. Source control, don't need to worry about that. Run and debug, this can be useful. We'll get onto that. And you may or may not have these down here. It's Jupyter, LiveShare, and Tab 9 AI Assistant. These are extensions. Not all extensions have a little icon here, but a couple of them do. 3 out of 50 that I've installed do. And this thing here that I skipped over is the extensions marketplace. And essentially this is these little they're extensions that you can install, and they add support for loads of different things. So for example, if you wanted to install a HTML extension to edit HTML in here, Python extension, a C# extension for Unity, and so on. And that's how Visual Studio Code has support for every single language. There are there are things that make your code a little bit nicer. So a couple of things I recommend. This rainbow brackets one, this is very useful. Subtle match brackets, this shows you, if you click on a bracket, it will show you the pair, the other bracket, which is very useful for C because there's a lot of brackets. Rainbow brackets, by the way, it gives each bracket a different colour. And I'll show you with and without just for fun. Tab 9, this is a bit of a cheat. And essentially it allows you to, it learns how you code, and then you can just start hitting tab and it will automatically fill in code for you. And it's pretty fucking good. It's not that bad. It's not that far off autocode, but it does make mistakes, so I don't rely on it. Pseudocode allows you to do pseudocode in Visual Studio, although obviously you can't run it. It's just a plan. Any other one that I like? Colorado? No, this was for HTML. Better comments. This is a good one. I'm sorry if I'm taking a while, but you can essentially, it gives you different colored comments for different things. So if you have an alert or like an important note, you can make them different colors. And yeah, there's just loads of different things. This is an Arduino one for Arduino C, which is how you program robotics. But yeah, you can have a look online if there's any that take your fancy that make your coding life a little bit easier. You can do that. But now we start C code for real this time. I appreciate that I've ambled on a little bit here, but I just thought I'd show you everything first. One more thing actually. Oh my god, I'm taking forever. Click terminal, click new terminal, and that's going to open up this little menu here. You can close it there, or you can open it up by dragging it up like that. And that's essentially a terminal. And this is a Unix shell, I think. Yeah, it's a Unix shell. So you can use all of your... Can you? Oh, no, it's not a Unix shell, it's just a Windows command shell, never mind. I'm really dumb. So you can't use all of your Linux commands unless you're on Mac or Linux. If you're on Windows, it's the standard, like a command prompt essentially. But this is where you're going to be running all your stuff eventually if you want to use terminal. So, first things first, you're going to want to go to your like C tutorial to start coding. Not C, your project folder. I'm really dumb. And you want to click this little plus button here that says new file, this one on the left. And you want to call this whatever you want. Like I usually call them main.c, but you can call it whatever you want. So I'm just going to call it main.c. You can call it fish fingers if you want. I don't know why you call it fish fingers. But this is your C file. This is essentially where you'll type your code, because the way that C works, it's not like Python in which you write your code and then you run the file and Python will translate it line by line in real time, for example. It's not like that. What C does is you write all of your code and then you use a compiler and it essentially gets all of your code and shoves it into an exe or whatever executable you're on. Windows is exe. Linux, I'm pretty sure does anything. Mac, I don't know what the Mac version is, but it will shove it into an executable, which you can then run even if you don't have your code file. And that's why C is useful. Whereas in Python, you always have to have the .py file to run it, and you also have to have Python installed in whatever environment you're running your code on, which is a pain if you're wanting to program, I don't know, robotics, for example. If you have a chip that you have to code for that's only got 6 kilobytes of memory and Python takes up 200 megabytes, you're fucked. So really, if you're dealing with very small amounts of memory, C is the way to go, because C doesn't do shit for you. You have to code so much stuff. Like if you have any experience with coding already, you'll know what a string is. Strings don't exist in C. You have to do it all for yourself. And I don't know why the uni has done this as the first language. I mean, I can see what they're going for, like really fundamentally understanding everything about coding. But sometimes when you just code it, you just want it to work. And it doesn't do much for you. And the error messages are fucking awful. Okay, anyway, enough rambling. Let's get to coding. So, before you start, you're going to want to click Terminal, and you're going to want to click Configure Default Build Task. Now this is essentially going to create the exe for you, so you don't have to mess around with the terminal down here. You can do it at the terminal if you prefer doing that way. You'll probably have covered that in the lab session, how to build a C file into an exe. I'll show you anyway, just to make sure. We'll do that later. But if for speed purposes, you can click this button and it will make it so you just have to click that play button and it will build everything for you and then run it. So it's nicer to use it this way. So configure default build task, and then you won't have 3, you'll probably have 1. You want to click the gcc.exe, that's the one you installed. If this doesn't exist, or if it's not showing you like a compiler and then like a path to something, then you probably need to restart either your computer or VS Code, or you haven't installed the GCC compiler. If you haven't installed the GCC compiler, or if you like, have I installed it? No, you'll know if you've installed it. And I might make a separate video if you need any help with that, because it's a fucking pain in the arse. It took me 3 days straight to figure out what the hell's going on. I used to use a different IDE called CodeBlocks instead of VS Code, and that one came with a GCC compiler, but this one doesn't. You have to install your own one, and I'm using mingw64 gcc.exe, and so I just click that, and then it's going to come up with this fucking complex looking thing. You don't need to worry about that. All you need to worry about is pressing the little close button and then minimizing that so we don't ever have to look at that bullshit again. And look at it, it looks fucking complicated. It's not actually that bad, but like, it looks horrible. So, now for coding. So, essentially, C is a compiled language. I've already explained this. It's based, once you've coded, it'll take all of your code and shove it into an exe in machine code form. If you don't know machine, it's essentially just ones and zeros. Basic definition. That's not a good definition for it, but just as a basic thinking about it, it's ones and zeros essentially. So it'll take your C code, turn it into the ones and zeros, shove it in an executable. Now, it doesn't do anything for us. We need to tell C exactly what we want in our code. So for example, in Python, you have something nice, it's called print. It prints a line of text on the screen. C doesn't come with that by default, so we need to tell it to include print and other things in our code before we start working with them. The reason it does that is because to save space. So if you are, again, coding for robotics, you don't want all this extra stuff that you're never going to use taking up space on your 6 kilobyte chip. You only want exactly what you need. So to include the standard sort of input-output stuff, so printing, getting information from the console, that's bright. Might close that actually. There you go, sorry. That just hit my eyes, it was really bright. And if you want that sort of standard input output, all you have to do is say hashtag include stdio.h, and what this means is we're going to include the standard input output library. Okay, and this is one of the ones that comes with many GCC compilers, all of them. I don't know what your compiler's doing if it doesn't have this one. That's all we're going to need for now. If you want, you can also include another one called standard library, but I'm going to see how we get on without that because you might not need that. Ooh, go away, Argos. Sending me advertisements while I'm making a freaking video. Anyway, so when the compiler, the GCC compiler, when it's building your code, it's going to look for a main function. Now, in Python, you can just sort of type whatever you want. A tab 9 coming in useful. You can type whatever you want and it'll go bang, bang, bang in that order, right? It will do the instructions that you type in the order they appear in the program. That's not how C works. C will look for a main function. If you don't know what a function is, just bear with me for a second. It will look for a main function, and the code inside that is what it will run first. So to create that main function, again, if you don't know what I'm talking about, just copy me just for a second, I'll explain it. We want to go int main, open and close brackets, and then you're going to want to create the wiggly brackets, I don't know what the name is for them, and press enter. Now, what this is it's a function. And a function is... Think of coding as a recipe for something. So, for example, I don't know what we're making today. We'll make a stir fry, right? So, think of coding as a recipe for a stir fry. If you have a big list of steps to make the stir fry, it's very confusing, right? So what you would do in a recipe book is you'd break it down into, like, make the sauce, cook the chicken, noodles. You try to get what I'm trying to say. You break it down into steps, right? And it's the same in coding. So each function in coding is like a little sub-step. So, for example, throughout your recipe book, let's imagine, I think I just hit my microphone. Throughout the recipe book, you don't want to repeat the same instructions for tomato sauce over and over again. You'll want to say at the start of your book, here's how to make a tomato sauce. And then throughout the book, you'll say, refer to this page at the start. It's the same in coding. If that didn't make sense, we're not going to use that definition now, but that's just a definition of what functions are. We'll refer to it later. See, I'm giving you the definition, and I'm just going to say, right, refer to this bit later. That was terrible. My cooking analogy was better. So, this main function is like the main part of the code. This is what's going to be executed first. And you'll notice that we have these wiggly brackets. These curly ones, don't worry about them for now. Just leave them empty. But all the code that's inside these wiggly brackets is what's going to be executed when we run the program. So, the main is just the name of the function. The main function always has to be called main, right? But yeah, all the code that we write inside the wiggly brackets is going to be executed at runtime. Also, don't worry, that's not code, that's me spamming the keyboard. Code makes a little bit more sense than this. Not too much more sense, but a little bit more sense. It's not just random letters. You'll also notice that this text I've written here, also it's screaming at me, telling me this is not code. The red lines will mean it's not code, like something's wrong. But you'll notice that this text here is indented. That's what this little space is called. And essentially that means it's inside a set of wiggly brackets. I don't actually know what the correct name is for those brackets. I'm just going to call them wiggly brackets. The indentation, it's just a tab. So, like, there you go. And essentially it means it's inside wiggly brackets. So all of the code that's indented inside these wiggly brackets will be part of this main function, which is what's going to be executed when you launch the program. So, for example, we can write our first line of code, which can be print f, open brackets, hello world, close brackets, semicolon. Okay? So, always in C, unless it's most 90% of the time, unless it's an include, unless it's an include or it's a set of wiggly brackets, you're always going to want to have a semicolon at the end of each line. That tells C, right, that's the end of that instruction, let's go to the next one, right? So that's always, unless it's an include, wiggly brackets, like defines as well, but we won't do that today, and switch cases as well. I'm pretty sure don't have semicolons. But again, we won't do switch cases today. And a few other things too, but I can't remember them off the top of my head. It's probably something obvious. Definitions for classes and stuff. So, back to coding. This printf is part of this standard input-output library. I'm pretty sure it is. We can check by doing that. Maybe it's not. I always thought it was part of the input-output library. Anyway, keep that in because you're going to need it. We can try running it without, just out of interest, in a bit. But essentially, this is a function that prints to the terminal, which is this bit thing down here, whatever you put in the brackets. Now, I'm going from the assumption that you've never coded before, so I'm going to explain this quite in depth. Well, not in depth, but you know what I mean. Like, I'm going to go like slowish with it. You're going to want to put whatever, if it's like a phrase or a word, you're going to want to put whatever you want to print in these double quotes, right? So these ones here, because C otherwise is going to do some funky stuff with it, and you're going to get a bunch of errors and stuff. So if you're going to want to print a phrase like "Hello World," I love fish fingers. I don't know why I'm thinking of fish fingers a lot today. You're going to want to put it in the double quotes. I almost said curly brackets. That's the name, curly brackets. So, yeah, close the double quotes. My God. Close the bracket at the semicolon, and we also want to add return 0 at the end and a semicolon. Now, with functions, we always have to return something. So, essentially, again, think of the recipe book. I do quite like using a recipe book analogy when I explain coding to people. Think of the make tomato sauce function. You have a make tomato sauce function. You run it, and it returns tomato sauce. Right? At the end of it, you get tomato sauce out of it. That's what this return statement does. It tells you what you get back from the function. And in the main function case, we want to return 0. 0 is good. If you returned a number higher, it will work, but it will just say returned with code that. And you can use the number to specify if something's gone wrong with the program. So, like, if you've ever had a blue screen of death, it'll give you an error code. That's what this is. It's like the code that returns out of it. 0 always is, it's run, there's no problems with it, it's good to go. So you want to include that at the end of the program. If you include a high number, like I said, it won't do anything bad. It's just like, write this code. It's like convention that 0 is the good one. So we've written our first C program. If we go up here, we can click either the play button to run with debugging, or just run. And it will build for us, and then it should say hello world down the bottom. Woohoo. Well done. If you've never coded before, that was probably really hard. Oh, it's Alt-Shift. Yeah, okay, this is useful, okay? So, moving on from hello world. Now, if you do have a little bit of experience with C, you're probably looking at that and being like, he's forgotten something. Well, I have, intentionally. So if you want a cool shortcut, you can hold Alt-Shift and press down, and it will duplicate the line of code that you're on. And if you want to go up, like if you want to duplicate it up, you do Alt-Shift up. Left and right does something different, but let's print a bunch of hello worlds and see what happens. So if you used to like Python, this should just go hello world, hello world, hello world, etc. Right? But it's not going to do that. I'll show you what it does. Hello world, hello world, hello world. It does it all in one line. And that's because C is so very kind to you that it doesn't even give you the new lines. You have to code those in yourself. So let's do that again. But instead we need to add a new line after every code, every line of text. We could do it before. It's just which one you prefer, or it depends on the situation. Generally before is what you use after if you get someone's input or something. We'll get onto that later, but we're going to do it for the end, at the end of each statement. So all this is a \n for new line, right? It's not a /n. It's not that. It's the \n. And this backslash means that this is like a special character. So this isn't. You'll never be able to print \n unless you use some, like, I think you have to type it in ASCII or something. So yeah, this is the new line character. So we can. Oh shit! It's Alt, not Control. We can Alt Shift down and repeat that, and we run it now. We'll see we have loads of hello worlds on new line. Perfect. So there you go. We have made our first C program. Hopefully it wasn't too much of a headache. And if you'd like now, we can do something a little bit more advanced. So we're going to do this one other thing. It's called variables. And then I'm going to set a little task and then probably show you the solution if we get time for that. I don't know how long I've been recording. Let me check. I've been recording 26 minutes. Okay, I'll probably not do that last bit. I'll probably make another video and then do that last bit, okay? So, variables. We'll do this first. And then I'll sign off, probably. Variables are different in C than other languages. There's loads of different types of variables, and you have to specify. This is for Python. If you're new to coding, ignore what I say now. But for people that use Python or another language as such, Python you can just say like x is equal to 5, right? In C, you'd have to specify what type of variable you're using and then set it equal to 5. So integer x is equal to 5, right? Okay, so if you want to have an experiment now while I explain for people that haven't coded before, go for it. But for people that haven't coded before, a variable I always think of as a box. So it's a box, right? It's a box in your computer, like a little virtual box, and you can put something in the box, and you can give it a label, right? And you can store it for use later in your program. So you can always change what's inside the box, but you can never change what kind of thing the box holds, right? So say you have a book box, right? There's just a book sat there. So you got a book-shaped box. You can fit a book in it. You can say, oh, this is my book box 1, right? And then if you say, oh, it's on the side, oh, get me what's ever in book box 1 to like your friend that's coming to your room. They'll go and grab the thing that's in book box 1 and give it to you. However, if you try and put, I don't know, a tin of pasta inside it, or tin of pasta? No, a bag of pasta inside the book box 1, it's in the shape of a book, so the bag won't fit, right? You can only ever put in to the box the thing that it was originally like intended for, right? But I'm doing that because like a book is like that shape, isn't it? But if you try and like, I don't know, put a canvas or something, I think this is a weird analogy. I have a very weird analogy. I hope they make sense. But if you try and put something into the box that it wasn't originally intended for, it's not going to fit. It's the same with variables. So in a more computery sense, a variable is a place in memory which you can store some data that you can use later. Alright? So the different types that I was talking about just now, they're different things that the place in memory can store. Like how I had the box for books. you could have a variable for numbers, or a variable for words, or a variable for characters, or a variable for... You can create your own custom variables and do a variable for a point on a graph, a variable for a person, right? Well, that would technically be more like classes and stuff, but it's the same concept. It stores a bit of data for you to use later, and you can't store a different type of data than what's intended in the variable. That will make sense very soon. We'll create a variable right now. So I'll save the cough, because that'll probably mess up the microphone. I have it quite sensitive. But for this program, let's create a variable that is a number, and let's set it equal to our test grade that we got on an imaginary test we did at some point. The coders in the textbooks always like to use school stuff. I don't know, it's just numbers in it. I would probably create some sort of like a coffee price thing. I don't know. I think that's a little bit nicer than a test grade. You know what? Let's do a coffee shop, okay? So we can go. Well, what's the price of something? It'd be like, I don't know, £1, right? Like £1.50. So to create the little box that's going to store our price, we can go float price equals 1.5 semicolon. So if you never coded before, this is probably gobbledygook, but I hope I can break it down after beating you over the head with that box analogy. So let's start off here. Float. This is the kind of thing we can put in the box, and float is short for floating point number, and a floating point number is essentially a decimal. A floating point number can have up to 6 decimal places of precision. There is also double, so instead of a float we could have double, which stores 10 decimal points of precision, but it also uses a little bit more memory. It's like, I think it's like 4 bytes is a float and 8 bytes is a double, or something like that. It's not, it sounds really like minimal, like 4 bytes and 8 bytes. Pretty sure, like, I don't know, Metroid Dread is like an 8 gigabyte game, so 4 bytes versus 8 bytes in this concept of a modern computer program is nothing, right? But in the sense of something like robotics, where you only have 6 kilobytes to store everything, you want to try and use the lower precision amounts. And anyway, we're only trying to do 2 decimal places maximum for a price, so I'm going to pick float. So float is the kind of data we're going to put in our in the box, right? It's the kind of thing we're going to put in our box in memory. Price is the name of it, so that's the thing we can refer to when we tell our friend, oh, go and get whatever's stored in the book box 1. So whenever we tell the computer, go and get what's stored in price, it will return whatever value we've set in here, which is 1.5. The F, I don't know if that's needed or not. I don't think it is, but I'm used to C code. I think the F will specify. So C is okay. I think it's just come into my memory why I used the F. That was something I added in after because I had a thought that it might need it. So C will always try and store things in doubles. So if I put 1.5 just as it is, that would be a double. That's that bigger data type that we said before. But we're storing it as a float. So you want the F to specify this is a 1.5 that's a float, not a double. So you could save the headache and just store it as a double. That would be fine. But it's better practice to store lower precision things such as prices where you only need 2 decimal places into something like a float because it's less precision. So we now have a thing in memory that stores the price of a coffee. Let's just say it's a latte. So we could also create a name for our coffee. So the way we do this in C In Python, we do the exact same, but the data type would be a string, right? Because a string represents a string of characters, because that's all a name is. Like, for example, latte is a string Latte, right? It's just a string of characters in the row. Now in C, it's different because strings don't exist in C. We could include string up here because there is a library that allows you to use strings like normal. But I'm going to teach you the old-fashioned way, which is give you a better understanding of what strings actually are. So we could store a car first, right? Now this stands for character, okay? And we put the little asterisk and we say name is equal to double quotes, just like the phrase that we did from print, latte. Okay? No squiggly red lines, so I was correct. And in fact, I'm going to remove that and I'm going to do square brackets instead. Now, what this is doing is this is something called arrays, which we'll go into later. But essentially, an array is a list of... It's a thing in memory that can hold multiple pieces of data, right? So imagine you had a book box. Again, I don't know what my obsession with book boxes is, but it's a book box. It's fun. It's fun to say. And it has multiple slots for books. Let's say it's 6 slots for books, right? You can slot 6 books into it at once and it will hold it all in this one box. That's essentially what an array is. But instead of books, it's a character array to hold multiple characters. Now, in C, you can't change the length of the array once you assign it. Little bit of a lie. You can sometimes, but most of the time you need to specify a length of an array before you add stuff to it. It's a good drink. So, for example, if you had that book box and it's, I don't know, you've made it and it's 3D printed or whatever, and it's got 6 slots for books, you can't just shove in a 7th book. There's no slots for it, right? Exact same in C. In something like Python, it will automatically do a memory allocation, so it like creates the 7th slot as and when you need it. In C, you can't do that. It doesn't do it for you. There is a way, but it's a bit beginner unfriendly, so we're not going to do it this time. We'll go into more detail of arrays later, probably next video. But for now, all we're going to do is we want to print out this information to the user. So we can use the printf thing before, and I would like to try and get it to say the price of a whatever's in name is whatever's in price, okay? So in this case, it would be the price of a latte is £1.50, all right? So printf the price of a, and for this you'll have to use %s, okay? I'll explain why in a second. The price of a %s is %f, okay? And then we want to do comma name price, okay? Close bracket, semicolon. Now, essentially what this is we don't want this just to say latte, right? We want it to say whatever's in this box so we can change it, hence the name variable. It varies, right? So say we want to do a cappuccino instead, right? Cappuccino, that's £2. It's not going to work if we hard code in that it's a latte, right? So we want to have something that we're going to be able to change just by modifying some code. So we have this thing called %s, and this allows us to insert a bit of data from a variable into the middle of our phrase that we use here. Sorry, Mum. Drink gassy. So what we do is we say %s, and this represents a string of characters, right? And then at the end of our phrase, we have a comma, and then we put our string that we want to insert into the first slot here as the first thing after this comma, right? So we also want a price, which is %f for floating point, %f, and after our name, we'll have a comma and say price, okay? So by the way, we can't do this any which way. We always have to do the comma, and then the one that appears first goes first, and then the second one goes in the second thing after the comma. And we also need our new line. Okay, so let's run this and see what happens. I hope you understand everything. So the price of a latte is 1.50000000. So this is the thing where you can see that a float has 6 digits of precision, whereas a double would have 10 digits of precision. We can change it to a double and see what happens. Oh, same thing. Yeah, same thing. Okay. So that might just be because we've not used it all. However, oh wait, not the same thing. Yes, it is the same thing. Oh, shit. What was that? There was a noise in my headphone. That spooked me. But yeah, there you go. So, the price of a latte is 1.500000. Now, obviously you can't have 1/100th of a pound. No, you can. That's a pence. Idiot. You can't have 1,000th of a pound. You can only have 100th or a 10th. So all of this information after 2 decimal places is useless, and it's harder for our brain to process because there's more numbers, and our brain is like, no, we just want the simple stuff, all right? So we want to chop off those extra decimal places. Now to do that, we can use these little things. I think these are called format tags. I don't know. I've got a textbook there. I probably should refer to it. But they are formatting things, right? These percent things. So it doesn't just, don't just tell, oh, we want a string there, right? We can do things with that string. Now we don't want to do anything. That latte looks fine to me. But this floating point, we want to chop off those two, or those other things, okay? So to do that, we do 1.2, okay? Now I'm going to test something really quickly, actually. You don't even need to do the 1, just 0.2, okay? And what this is going to do, ignore the 1, that's for something different. What this is going to do is it's going to reduce the floating point to a 2 decimal place number, 0.2, right? So the thing after the point, this thing before the point is something else. I'll probably explain it later. It's called column spacing. It just shows you how much space is in between it. I'll give you a quick demo now. So we set it something like 7 and run it. Run. We see there's a lot of space between there and the last thing. But you don't need that. We just need 0.2, right? And that's going to restrict it to 2 decimal places. I think it will round up. So if we do 556, we can test that. So if this is 1.56, it rounds up or down depending on which one, right? However, we want is 1.5, so bang, and it's 2 decimal places. And then the new line means we could Alt-Shift and spam it, and we can really emphasize the fact that the price of a latte is £1.50. However, that's how you print out variables and store variables in C. Other types of variables, there's ints, which are whole numbers, stands for integer. Floats, which are low precision decimal place numbers. Doubles, which are high precision decimal place numbers. Characters, which are individual characters. Character arrays, which are strings of characters. And longs, but you don't need to worry about longs for now. Those are the main ones, really. There's no booleans, which some of you will be happy about, although you do have to use integers as booleans instead, which A little bit of a trade-off there because integers as booleans. I don't know, because I just prefer a true or false, to be honest. And there's no strings, which is character arrays. You can create your own types with typedef and structs. However, new coders, that probably went whoosh. Even experienced coders, it probably went whoosh because you probably know it as classes. It's sort of similar. It's not that similar, but it's similar concept. All the experienced coders are like, no, it's not. A struct isn't a class. A class is a class. But yeah, that's all I wanted to cover in this video. Hopefully that's helped with the basics of C. Next video, we'll get onto something a little bit more advanced, and we could do a coding project on video. Awesome. Amazing. Thank you for watching. If you have any questions, this is obviously a public YouTube video, so leave them in the comments or email me, or just send me on Snapchat. I'm in the group chat, so if you don't have me on Snapchat, then ask someone who does. You can recognise the Bitmoji. It's pretty accurate. But yeah, I hope that was helpful to everyone, and I'll see you guys all next time, and hopefully be doing something a little bit more advanced. See you in a bit.